Okay, we can start now. So, Ala,
Yes, okay.
yeah, okay.
Hi everyone, my name is Ala At-Tarazi. I am the Developer Technical Support Engineer in Huawei, and I'm here to talk about augmented reality kit provided by Huawei. Before I start, I want to talk about Apps Up Contest a little bit. Huawei App Gallery and HMS Core offer a complete development and publishing solution for app developers. With Huawei Apps Up Contest, developers will now have the chance to win massive cash prizes. The Apps Up contest lets developers present their apps to an audience of over 650 million active monthly users. The contest is being held in Europe, Asia Pacific, Middle East, and Africa, Latin America, and China. Huawei has dedicated $1 million in prize money that will be given to winners from different categories. Winners will be selected for the best app category, best game, best social impact, most popular, and honorable mentions. We started this contest end of June. The works collected and live workshop will continue until end of August. In September 21, we have announcement for top 20 apps. After the announcement, we have works exhibited and public review. The final awards ceremony will be in October. The contest will start with all the submitted works. After preliminary expert reviews, only top 20 apps will move to the next stage. The top 20 apps will display their work to the public. Finally, the judges will choose the best 8 apps from the 20. There are two basic requirements to submit your app. The first one, you need an innovative app in diverse fields. We prefer if the app is released on Huawei App Gallery. The second one, the app must be integrated with HMS Core and other open capabilities provided by Huawei. Also, we have $15,000 for the top 5 most outstanding apps, top 3 most outstanding games, top 3 most social impact, top 3 most socially impact apps, and $5,000 for most popular app. Also, we have $2,000 for 12 honorary mentions apps. My colleagues are already talked about different Huawei kits in previous workshops. The contest started in July 13, and in July 15, the first workshop started. It's talked about Huawei Toolkit. In July 20, BushKit, and July 22 about AdsKit, and finally in July 27, my colleague talked about Huawei Analytics Kit. Today I will talk about augmented reality, and the final ceremony will be in October 15. If anyone have any questions about the contest, you can contact us on appsup.mea@huawei.com, or for any updates, you can follow Huawei_devs in Facebook or Twitter. Let's talk about augmented reality now. Augmented reality holds the promise of creating direct, automatic, and actionable links between the physical world and electronic information. And to provide a simple and immediate user interface to an electronically enhanced physical world. So you can control your entire home with your hands or your body without using any physical electronic devices. You can monitor your emotional status if you are sad, angry, or happy. And based on it, your device suggests to listen to a specific music or go to a trip to enhance your mood. You can use this technology everywhere. There are infinite numbers of ideas you can use in your business or app using augmented reality. Now let's talk about it in details. I will describe the functions, advantages, and a lot of features for Huawei AR Engine. There are three main functions for augmented reality. Motion tracking follows device locations and positions relative to their environments and establishes a unified geometric space between the digital and physical worlds. Environment tracking records illumination, plan, image, objects, surface, and other environmental information to help you to, to help your apps merge virtual objects into scenarios in the physical world. And we have human body and face tracking. Returns real-time information about human body's face and hand gestures for your users to interact with virtual objects. Now let's move to the advantages. We have software hardware optimization, streamless modules, chips, algorithm, and emotional UI with hardware acceleration to provide better and greener augmented reality effects. Differentiated capabilities offers gesture and body recognition and interaction, thanks to unique hardware of Huawei devices, in addition to environmental understanding. Finally, we have multi-device support, integrates with a diverse range of Huawei devices, and has already achieved more than 400 million downloads. Now let's talk about the features. First of all, we have motion tracking. As your phone moves, Huawei AR Engine uses visual inertial navigation technology to understand the position and posture for your phone relative to the surrounding world. Huawei AR Engine detects feature points in captured camera images and uses them to calculate their position and posture changes. Plan detection. Huawei AR Engine continuously improves its understanding of the real world by detecting feature points and plans in the surrounding environment. For example, Huawei AR Engine can find clustered features that appear to be one common horizontal surface, such as seats and tables, and enable these surfaces to be used as flats by your app. Huawei AR Engine can also determine the boundaries of each plan and provide this information to your app. Hence, you can use this information to place virtual objects on a flat surface. A light estimation. Also, Huawei AR Engine can detect information about the surrounding ambient light and provide you with the average light intensity for a given camera image. This information enables you to illuminate your virtual object with the same lighting as your surroundings, enhancing, enhancing their realism. Orientation points. Orientation points enable you to place virtual objects on non-horizontal surfaces. Also, we have anchor points and traceable objects. The position and posture of your phone will change as Huawei AR Engine improves its understanding of its location and environment. When you want to place a virtual object, you need to define an anchor points to ensure that Huawei AR Engine can trace the position of the object over time. Also, we have another features like hand gesture recognition. Huawei AR Engine provide recognition of 6 particular hand gestures. The recognition result includes gesture ID and hand bounding box. When the camera captures multiple hands, the engine only output the result of the hand with the highest confidence value. Left or right hands can be robustly detected. The engine supports front-rear cameras switching. Using hand gesture recognition, you can overlay virtual objects on the hand position. Additionally, you can active certain state switching by hand gesture, which provide novel interaction for your augmented reality applications. Hand skeleton tracking. HUAWEI AR Engine can detect the joint and skeleton of a single hand and outputs advanced features like fingertips, hand orientation, etc. Also, we have human body pose recognition. The HUAWEI AR Engine provides single body gesture recognition, identifies 6 static body poses, and output recognition results. A human body mask. HUAWEI AR Engine support recognize and tracking of outline of a single human body, outputs human body mask and information of skeleton points. And finally, we have face mesh. The HUAWEI AR Engine provides high precision face mesh modeling and tracking capabilities. After acquiring face image information, a realistic mesh model is created in real time. The mesh model changes its position and shape as the face moves, achieving the effect of real-time precise follow-up. Also, we have an important feature for HUAWEI AR Engine. It's head testing. HUAWEI AR Engine uses head testing to obtain the X and Y coordinates corresponding to the phone screen and projects array into a cameras, returning the position and posture of any plan or feature point through which the ray passes through. This enables you to select objects in the environment or interact with them. The human body skeleton, HUAWEI AR Engine support recognition of joint and skeleton of single and multiple human body, and output advanced features like nodes of arms and legs, body pose, and body skeleton. The engine can also output 2D and 3D skeleton. Also, we have image tracking. HUAWEI AR Engine provides image recognition and tracking capabilities to detect whether there is a user-provided image in the scene and to recognize the pose of the image afterwards. Facial expression tracking. HUAWEI AR Engine provides the ability to track facial expressions, track and capture facial image information, and understand adult faces' facial expression in real time and convert them into various expression parameters. The expression parameters can be used to control the expression of the avatar. As we already see, there is a lot of features for HUAWEI AR engines. We can summarize all the features under 4 categories: word, body, face, and hand detection. Word detection support the motion tracking capability so that the device can perceive and track its location and pose relative to the real world, understanding the surrounding environment so that the device can detect and identify the size and location of various plants, such as seat, wall, or even tables. Estimate the illumination so the device can know the lighting intensity in the current environment. Body detection. This feature identifies and tracks 2D locations for 23 body key points or 3D location for 15 body key points and supports the tracking of 1 or 2 people at a time. The body tracking capability allows you to superimpose virtual objects on the body with a high degree of accuracy, such as on the left shoulder or right ankle. You can also perform a greater number of precise operations on the avatar, enjoying your AR apps with fun functionality. This is the mapping between return values and actions, so you can integrate these actions with events from real world. So each action you can do with your body, it's return a value. This value you can control something from real world. Okay, we have face detection. HUAWEI AR Engine provides this capability in order to track and obtain facial image information, comprehend facial expressions in real time, and convert the facial expression into various expression parameters, thereby enabling the expression of virtual characters to be controlled. Also, it supports the recognition of 64 types of facial expression, encompassing the eyes, brows, eyeballs, mouth, and tongue. Huawei AR Engine provides a mesh with more than 4,000 vertices and 7,000 triangles to precisely outline face contours and enhance the overall user experience. Finally, Huawei AR Engine can identify multiple types of gestures as shown in the figure. As in the body actions, you can perform a specific event for each action with your hand. For example, turn on or off the lights, play music, open garage door, etc. Please note that when there are multiple hands in an image, only the recognition result and coordinates from the clearest captured hand with the highest degree of confidence are sent back. Gesture recognition allows you to place virtual object in the user hands and activate certain status based on the change of hand gestures, providing for fun interactions with your augmented reality app. And we have hand key point tracking. This feature identifies and tracks the location and poses of 21 hand key points to form hand skeleton. It also distinguishes between the left and right hands. That's all. Thanks for your time. If you have any question, please post it in the messaging box or session chat.
If you have any question, please post it in the questions section and we will answer it after the session ends. And now we should start uh, a session from Totok co-founder. Answer it after the session ends. Hello.
My name is Giacomo. I'm the co-founder of Totok. Totok is a free, secure, and easy-to-use messaging and calling app with the goal of connecting friends, families, and colleagues from all over the world beyond borders and without any limit. Thanks to its beautiful user interface, superior audio-video calling experience, and unique features, in the past months we have been witnessing rapid growth across hundreds of countries around the world. Since our launch, we've been integrating several Huawei kits within the Totok, such as push, location, maps, hand AR, face AR, and high AI video segmentation kits. So the Huawei Push Kit is extremely important for an instant messaging app like Totok, and it allowed us to reduce the rate of missed calls and messages dramatically, especially due to the fact that notifications are delivered even when the app is running in the background. The location and map kits are also crucial for our users as they allow them to share location faster and more accurately on Totok. Huawei AR and high AI kits allowed us to embed advanced technologies such as augmented reality and artificial intelligence within our Totok video calling experience. The use of these kits resulted in the creation of new fascinating features such as the hand gesture filter, the Q emoji filter, and the video background filter. So the use of the push kit had a very positive impact on our user experience since we witnessed a decrease on the rate of missed messages and missed calls, which eventually made it easier for people to stay connected. Since our launch, Huawei has been one of our most valuable partners. The support we've been receiving from them has been tremendous and ranged from the coordination on promotional activities to technical support when it comes to the integration of the new kits to develop unique features within our product. I would love to take this opportunity to express our gratitude to Huawei, and may our partnership become even stronger and closer in the future. Together with Huawei, we look forward to create new digital experiences for the whole world.
That's all from our from CB side.
So now we can start the live code lab.
Hi again. Now I will guide you to write your first augmented reality application using HUAWEI AR. But before I start coding, we need to understand the structure of HUAWEI Engine and how it's work. HUAWEI Engine consists of multiple classes. The main classes in the engine are AR Session, AR Frame, AR Camera, and Texture Display. Those classes cooperate with each other to recognize objects from the real-world environment. For example, they can recognize human body, human face, and human hand, in addition to the plan, like surfaces, seat, wall, etc. The backbone of the AR engine is AR Session class. From AR Session, I can generate the frames, I can open the camera, and I can draw in the camera and put 3D object in your hand or face, or even in the environment in general. Now let's create our project. Start a new Android Studio project. I will choose no activity. We don't need any activity for now. Let's call it AR project. And we can use Java and Kotlin code. For now, I will use Java. Now I will talk a little bit about our code labs. You can visit our code labs from the developers.huawei.com, and you can go to the community code labs. Code labs provide sample code and instruction for all kits provided by Huawei. Today I will talk about AR engines, so let's focus on AR. In the code lab, you can find a brief introduction about AR and what you will create and what you will learn about it. And there is some requirement you need take it under your consideration, like hardware requirements. You need the laptop or desktop. You need a Huawei phone that supports our AR engine. And also there is some software requirements such as Java, JDK 1.8 or later, Huawei Dev Eco Studio or Android Studio 3.1 or later. You have to get the latest Huawei AR Engine SDK and latest Huawei AR Engine APK, which is available in Huawei App Gallery. Also, you have to know basics about Android development and some basics about OpenGL development. OpenGL is an open source library. You can use it in multimedia. You can use it in object recognition. Also, there is a demo. You can download it and run it in Android Studio to understand more about Huawei AR Engine and how you can use it in your app. Some guidance for creating your first app, and if you want to do some customization. Also, there is a development guide and sample code and the SDK you can download it from here. Now we need to add the Huawei dependency and the AR engine dependency in the build-to-Gradle files. Okay, let's start with Huawei Maven and add it in the repositories. Also here on the project repositories. Okay, then we open build-to-Gradle file in the app level. We have to add AR Engine dependency, and the version is 2.12.0.1. This is the latest version for the AR Engine. And I think that's it. Now sync the project, and we will wait until it's finished syncing. Okay, that was fast. Okay, good. Now we will create our first activity. Just choose empty activity. Make it launcher activity. Okay, Java. Let's add some buttons in our main activity. Let's call it BTN and I will start with a hand recognition. Activity. Okay. One, two. Let's set on create events. Now let's create another activity. Or before we create another activity, we need to add the camera permission and the manifest file with the permission. Now, in the main activity, we need to request the camera permission from the user. Now we need to initialize an array of strings. This array has all the permission we need, which is just the camera for now. So private for example runtime permission string manifest permission. Now we need to check if the app have or has the permission to open the camera. There is already I implement a function called has permission and received context and permissions, array of permissions. Need to check. Now import all the classes. Now let me share my screen and ensure that the permission is appeared correctly and the app is running correctly. start the app. Now the permission is appear to the user correctly. Everything is okay for now. And there's nothing in the button. I didn't put anything in the button. Okay, now we have to create a new activity. Let's call it um, in this activity, we will add service view. This service view can open the camera and open any frame I loaded from the AR session, as we discussed in this structure. So we have the GL service view. I will put it inside the AR session, and from the AR session, we will create AR frame, and from the frame, we can read this frame from the camera. So it appears to the user like I open the camera and start recognition. So first of all, we have to add GL service view. Yes. Also, I need to add text view just to appear some information in there, like the frame rate and any information I need to put it in the screen. Let's create text color resource. Okay. So, so we have GL service view. So we can show in it the frames. In my case, the frames will be views from camera. And we have text view. I need to write some information in the in the activity. Okay, let's back to our AR and AR activity. And just to initialize some properties for GL service view and the text view that we already created. From here, find view by ID for the text view and the service view. Now we need to set some configuration values for the OpenGL. I prefer to keep this configuration as it is because it's related to the OpenGL library, not to the AR engine. Okay. Now I have to create a new class called HAN Render Manager. This class implements from GL service. Okay, now I have to implement the unimplemented method. Okay, there is an re-override method on service created, on service change, and on draw frame. There is some value, default value for the AR engine. I will put it now. We have the tag. So if I need to write anything in the log, and some parameters, config parameters for the AR engine. Now I have some common classes like texture display, as we discussed in the structure, texture display. Also text display. This text display, if you remember, we add text to view in the activity right on the to write in the screen some information. And because the screen is in different thread, not in the main thread, so I cannot change the text view directly. So there is a class handle this thing. We can just edit. We can just edit the text and directly change in the in the in the thread. For the common classes, I have to create a new package, call it common, and add all the classes. You can find this class in the demo. That's because the R, and we change the path. Put something here. And this may take some time, but it's better than creating all this from scratch, because we don't have a lot of time and is already implemented in the demo. So you can take it as it is. You don't have to rewrite this code from scratch. So the manager now, let's back to the manager, import all the classes. Actually, we don't need this for now. Maybe we can add it later. Now let's implement the overriding on service created. What we need to do on service created. First of all, we need to clear any original car and set a new car, because this gets called when we the first time the GL services view is open. So if there's any previous color, we need to create it. Also, we need to initialize the textural display and set a listener the text display. As I said, this text display is used to change the view in the frame. Okay. This method is responsible to change the text in the UI thread. And now back to service created. Okay, now that's all for the service created. Go to the on service change. Also, we have to change that textual display. Like this. So we need to change the height and width for the OpenGL library, the GL report, and update the view rotation, port rotation, because on server change it's changed like 30 times per second. So we need to change the rotation and change everything in the screen. Now on drop frame, we need also to clear the color buffer in the OpenGL library. Some validation in the session. Also update session display geometry. We need to add this to update. Yeah. Now let's try capture the code. All the previous code that we created and all the classes, it's like a code structure, and set some configuration for the OpenGL and the AR engine. Now here we will put the most important code in the HUAWEI AR engine. It's all related to this structure. First of all, we need to link camera texture name to the texture display that we created, and we initialize it in the only service created. Also, we need to initialize the AR frame from the session update, and we will create the AR camera from the frame. So we need also to initialize project matrix. It's a matrix 4x4 and it's empty for now. This is to obtain the projection matrix for AR camera, and we give it all the configuration that we initialize before, and draw the frame inside the texture display. It's related to the later. The layout is related to the GL surface view. So this code is related to the surface GL view. Now I have to talk about the most important function in the library. Get all traceables. This function retrieves objects about the recognitions object in the environment. For example, if I send AR hand plus as a parameter to this function, it returns all the recognized hands in the environment. And hands contains all the information I need about that hand. Let's see an example.
Here we have a lot of functions that we can use to get information from the hand recognition AR.
The AR engine can recognize it and return it as a number or integer, as we say in the presentation at the first. So let's try this method. Okay, but we have something we have to do in the main activity. Start the hands AR activity. The manager. That way on the field.
Here I have to define the constructor for the manager. And also implement some set methods like set display, rotation manage, and set text view. This is just a setter for display rotation manager, and also a setter for text set text view.
Let's start بالعاب. Oh, before that, we have to add the zoom method.
Here I had override method on resume, and I will declare some properties. Here we have the AR ability check. It's checking if the AR engine is installed on your device. So I have to get this function, and because if the AR engine is not exist in your device, it's open the installation page and in app gallery, and you can install it from there. Okay, I define the AR session and put the setter for AR session in the manager class. define some methods. Here, because I changed the package name, so I have to delete this package. Okay. This method is responsible for the stop session. So if you want to stop the session, we have to call it. Here, we check the AR engine ability, initialize the AR session, and define the configuration for the camera. Here, I want to use the rear camera, not the front one. Also, I can control the power consumption for the AR engine. I can do it performance first or ultra power saving. Okay, and set enable depth. This configuration is enable depth feature in the device. So it can take the image in 3D, not 2D. And set all the configuration to the AR session. That's all now. I want to run the project. Rebuild it first. Okay, this is because the package changed. Rebuild it again. Oh, I forgot to delete this package. Let's rebuild the project again. It should work now. Okay, let's run it now.
Now the app is running. It crashed. Come on. We have in the resume.
Yes, this error because I didn't initialize the display rotation manager. Okay, let's run again. Now the camera is open, but as you see in the left top corner, there's a text view that I put in red because it's text view since um, the AR is not work. So there's exceptions in the log about null object reference. So if I have to search where's the null, it's null. Okay, I add some validation if there is no hands in the screen. Now I run it again, but it didn't work yet, and the exception is still appears in the log. It's still not work. I think it's related to the activity. I didn't initialize the activity in the constructor. Yes, it's not initialized. No, the app should work. I hope so. Yes, as you see, there's in the left top corner -1 number. This number is the gesture type for the hand. When I do a fist, it's convert to 0. If I do this, convert to 1. Based on the and there is multiple gesture types. You can see it in the as I said in the document or in the presentation previously. So that's all for the code lab. So I just uh, explain about the hand recognition and the gesture types of the hand recognition. That's all for now. Thank for listening. And if you have any question, please write it in the questions or in the chat session. Thank you.
Thank you, Ala, about this session. Actually, we have one question. Someone asked, will Unity 3D be supported? Actually, yes. If you search at the Unity plugin, you will find all the service plugins. That contains account kit, in-app purchase, ads, and the push notification, and game leaderboard. You'll find a lot of things actually. And for the augmented reality itself, you can also create the object from the Unity. You can use the same object at the AI capabilities. So if anyone have any questions, still you can ask at the questions area.
Okay. Thank you, Ala. Thank you, Omar, for joining us. Thank you all for joining us.